Imagine you're whispering your deepest secrets to a friend in a crowded room, but instead of whispering, you are actually shouting and everyone can hear. Without end-to-end encryption, this is exactly how your private messages are sent across the internet. Your personal conversations, financial details, and even your business information completely exposed. In this video, we would explore the two ways in which this encryption is achieved. Okay, the first method is called symmetric encryption. So let's revisit our previous example. You are trying to whisper your deepest secrets to a friend in a crowded room and you have no option but to shout. Okay, so what you can do is to render the message useless for anybody that is listening, even if they can hear it, but in such a way that your friend is able to understand the message. A typical way to deal with this is by speaking another language your friend can understand. In computer science, this process of changing a text or a message from one form to an unusable form just to be changed back is called encryption, and the process of changing it back is called decryption. There are different types of symmetric encryption algorithms. We have the AEA, the Advanced Encryption Standard, we have the DEA, the Data Encryption Standard, and lots more. What the algorithm does is to take your message, add a password to it, which you are going to be referring to as the key, to produce some gibberish. This process is called encryption. So this gibberish is sent to your friend, and when your friend receives it, it takes the same password, then performs an algorithm on it to give the original text, and this process is called decryption. So basically your friend decrypted the message while you encrypted the message before sending to him. This process of using the same key to encrypt and to decrypt the message is called symmetric encryption, because we are using the same key, so it's symmetric. If you're enjoying this video so far, consider liking and subscribing. Let's look at how you can achieve this in code. I've left the link to the code in the description if you want to check it out. I'll be using Python to describe this example. So the first thing that I'm doing here is to create an abstract class to basically define the interface for the encryption handler. So it has the encrypt message, decrypt message, get encryption key, and get decryption key. We're going to see why shortly. For the symmetric encryption handler, I'm extending the abstract class. Then when I initialize this class, or an instance of this class rather, I create a key. So I'm using Fernet to generate key, do the decryption and the encryption for this symmetric handler. And Fernet under the hood uses AES, which is Advanced Encryption Standard. So we are basically using AES. Okay, so to generate a key, we just call fernet.generate key. To encrypt a message, we get the encryption key, initialize Fernet, and encrypt. Then the last thing we have to do is just to return the encrypted message, which is the gibberish. To decrypt the message, we pass in the encrypted message, initialize Fernet, decrypt, and return the decrypted message. So let's look at an example. I initialize the handler, I get the message, encrypt the message, print out the message, which is what we are getting here, encrypted message and some gibberish. Then to decrypt it, we just pass the encrypted message to the decrypt method and we get our value back. So let's also take a look at another example where the decryption is going to fail. You have your handler 1 and handler 2. So they are basically two different handlers with different keys. So if you encrypt this message with handler 1 and print out the message, you get this. So let me rerun this. Okay, so you get this message here. If you are trying to decrypt it with the second handler, basically you are trying to decrypt it with another password or another key, then you get an error, which is this decryption fail. Assuming it was able to decrypt the message, it will print this, but it's printing this because we are catching the exception here. Well, that is symmetric encryption. So I guess that's all. But what if that's not all? What if someone gets a hold of your key or your password? Because the main issue with symmetric encryption is key management. Anyhow you go about this, you need to find a way to send the key or the password to your friend, and you can send this via email, WhatsApp, or any other way that you can send it. But the issue is, if someone gets a hold of the key, they can encrypt your message. So that message that is gibberish that you are broadcasting can easily be intercepted by anybody and decrypted. So this brings us to the asymmetric encryption. The asymmetric encryption ensures that we don't have this problem. So it works in such a way that, okay, what if I give you a key, that you can only use to encrypt, and I will privately keep a key that I can use to decrypt. And the key that I give to you is called the public key, and the key I keep to myself is called the private key. The private key is meant to be kept private, so it shouldn't be sent over the network or in any other way. It should be kept locally with you. Then the public key can be given to your friend, and if someone intercepts the message and gets the public key rather, the person would not be able to decrypt with it. They can only encrypt with it. It then means that if he wants to send me a message, he encrypts with my public key so that I can decrypt with my private key. And if I want to send him a message, I would need a copy of his public key to encrypt the message, send it to him, then he would decrypt with his own private key. Since by using asymmetric encryption, we've been able to solve the symmetric encryption issue, does that mean we don't have to use the symmetric encryption? No, it doesn't. And I'm going to discuss this in my next video. So you can do well to subscribe and like this video so that you can get notification when I post that particular video. It will talk about the shortcomings of the symmetric encryption and the asymmetric encryption. In fact, there are things that use both. For instance, your HTTPS, your secure HTTP uses both, and I'm going to discuss that in particular. So let's take a look at an example to understand the asymmetric encryption better. For the asymmetric encryption, we are using the asymmetric encryption handler class to handle this, and it is very similar to the symmetric encryption handler class because they both extend from the abstract encryption handler class. When we initialize this handler, we get a private and a public key. That's, we generate a private and a public key, and we are using the RSA algorithm to generate the private and the public key, and every other thing remains the same. To encrypt a message, we get the message and the key. If a key is not passed, we use the public key. Since when we are encrypting, we use the public key. When we are decrypting, we use the private key. So we encrypt our message and return the encrypted message. To decrypt it, we get the encrypted message, we pass it to the decrypt message method. We decrypt it and we return the decrypted message. And if you take note, while decrypting, we use the private key, and while encrypting, we use the public key. These methods are just to get the encryption key and the decryption key. The symmetric encryption handler will return the same key for both, but for the asymmetric, we return the public key for the encryption and the private key for the decryption. And this is an example to illustrate how the encryption and decryption works. So here we initialize a handler, we get the message. This is a confidential message. Then we pass the message to the encrypt message method. And what this does is to encrypt the message using the public key of the handler, as we can see here. So this is the encrypt message. It uses the public key to encrypt the message, then return the encrypted message. So we print the encrypted message here so that we can see what it looks like. So this is what the encrypted message looks like. It's just some sort of gibberish. To decrypt this message, we pass the encrypted message into the decrypt message method, which uses the private key. As you can see here, it uses the private key to decrypt the message, then sends the decrypted message back. So on this line, we are printing out the decrypted message. Okay, this is also an example to use a wrong private key to decrypt the message. So we have two handlers, 1 and 2. Both of them have a public and a private key. We get this message and encrypt it with handler 1. So we are encrypting with public key 1. Then we print out the encrypted message, which is what we are getting here. Then to decrypt it, we can use the handler 2, which will be using the private key 2 to decrypt the message, and this should fail. As we can see here, decryption failed. That means this line wasn't printed and this line was printed, so the decryption failed. To illustrate my friend and I communicating over a network using either symmetric or asymmetric encryption, I created a user class, and the user class is very direct. It has an attribute ID to identify a particular user. Then you pass in the name that you want for that particular user. Then we have the keys dictionary to keep track of the encryption information. The first method we'll be looking at is send key to user, and what this method does is to create a handler for the appropriate encryption type. Since the encryption key is what the second user will be using, so we send the encryption key to the second user and tell the second user the kind of encryption it is. So that's what we are doing here. Then once we get the encryption key of the second user, since that's what we will need to send message to the user, which is the public key in the case of the asymmetric encryption, and just the key in the case of symmetric encryption. Then we save it in our dictionary, our keys dictionary, to keep the information. But let's look at what happens when a user receives a key. So when the user receives a key, they create a handler for themselves depending on the kind of encryption type it is, and send the encryption key back to the user, which is what we are getting on this line. Once the user gets the encryption key, then they also save it. So both users will have their own set of keys, their own encryption and decryption key, and also the encryption key of the second user. Yeah, so this is the method to send a message. So first, we want to check if we have the keys for a particular user. That's what this line is doing. If we don't have a key, then we cannot send a message to that particular user. We cannot send an encrypted message to that particular user. So on this line, we get the encryption info, which holds our encryption handler and the encryption key of the second user. We can use our encryption handler to encrypt the message using their own encryption key. You understand? We need to encrypt it with their own encryption key so that they can decrypt it on the other side. So once we've gotten the encrypted message, we send it to the user. And since we are actually not on a network, I just call the user receive message from method. And what it does is it will get an encrypted message, check if we have a copy of the encryption key of that particular user, then we try to decrypt the message. We get our handler and try to decrypt with our own decryption key, which is what we are doing here. So we decrypt with our own decryption key and we print out the message. Okay, just to illustrate this, I created two instances, one Alice, one Bob. And Alice sends the key to Bob, sends a message, and Bob also sends a message. And we can see from the log, Alice sends a key to Bob, Bob receives the key, sends Alice back his own key so that Alice can also save it. Then Alice sends a message to Bob, hello Bob, this is a secret message, which is what we are logging here. Bob receives a message from Alice, hello Bob, and here Bob responds with hi Alice, which is this line here. And also the same thing for the symmetric key. So in this example, we can see that sending messages using the asymmetric encryption and symmetric encryption, they are very similar, except for the fact that in the case of the asymmetric encryption, we are using the public key to encrypt and the private key to decrypt, while in the symmetric encryption, we are using the key to both encrypt and decrypt. And the issue usually lies in key management. So when we know that there's a possibility of our key getting compromised, we tend to use the private and public key pair. That's the asymmetric encryption. And when we are sure that there's nothing like a compromise for sending or receiving of a key, we use the symmetric encryption. To elaborate on this, I will releasing a video talking about the pros and cons of asymmetric and symmetric encryption and why you might want to use and not use them, or use them in combination, and using HTTPS as a case study. So if you want to get notified when I release this video, do well to subscribe and hit that notification bell. Happy coding. Bye.